what I want to do is I want to review iterators and iterables. I know we're probably quite ecstatic about that, but it is a very important topic. And so our goal now is going to be, I want to write an iterator for the linked list. So that way I can use a for loop to go through my linked list. So how do we do that? Well, basically to make a linked list a iterable, we need to have the iter method. So we need to have some iter method. But what does the iter method have to return? Well, that has to return some iterator. So I'm going to return some iterator. So what's going to be our iterator? Well, we could have it as a representation of our own inside this class. But see, the problem is we're going to have to be going through the linked list one by one, right? It's kind of hard to go through a linked list and have a representation of a linked list at the same time. So this is why I believe in when I first introduced iterators, I made a separate class for an iterator. So this is why sometimes it can be useful to have a separate class. Sometimes you can get away with making it in the same class, but generally it's not a bad idea to make it a separate class. So I'm going to make a linked iter. So this is going to be my iterator basically for, wait, let me make sure I have a colon there. My iterator for linked lists. Okay, great. So, well, what's this iterator going to need? Well, we know an iterator needs to have a way to keep track of elements, and that's going to be through the next method. So we're not exactly sure how that's going to work, but also we know that every single class is going to need a constructor. So let's define a constructor. So the first question to ask yourself is, what do I need to really have to iterate through a linked list? So it actually turns out to be quite simple in terms of what we need. We only need a reference to the linked list, because then we have a way from going to the start to the end of the linked list quite easily. We just go through every single rest until we get to the end. So that's going to be the key idea here. We just need one reference to the linked list. So as a result, we have an instance attribute that's bound to link, and then we also need some notion of, remember, when we end our iteration, we want to start over, right? Remember that example from earlier where if we didn't have a way to start over, we would just never be able to iterate. We would only be able to iterate through it once and then we'd be done. So we want a way to start over, so we need to have a reference to the first link. So I'm going to have the first link equal to whatever the link is. And the reason I need this is because this reference to link is going to change. This is going to change. Okay? So then how do I get my next element? Well, first I need to basically take my linked list, my reference to my linked list, get the first item from it, and that's my result. And then my self.link, my reference to my self.link list has to change, because now I'm going to move through the linked list. And so the way I do that is I just do self.link, and I go now to the rest of that. So this is similar to how we do linked lists in general, except now we're doing it in terms of instance attributes. So don't get confused by these multiple dots. It's basically the same thing, because self.link returns a linked list, and how do we get the rest of a linked list? We just do .rest. And then so this is a way, and then we return result. But obviously this is not done, because we need to have some way of stopping iteration if we get to the end of the linked list. So how do we know we're at the end of the linked list? Well, if it's the case that my link, or better yet, I should do it in terms of my reference, is link.empty. So if my link is link.empty, well, what I need to do first is I need to start the linked list over. So I need to have I basically need to reset my self.link to whatever the first link was. What's my first link? Well, I have an instance attribute for that. So this is why I kept this instance attribute. This is why that's important. And then I, of course, have to raise stop iteration. Okay, so this is our linked list iterator. So now obviously we're not done yet, because we need to return some iterator. Well, now we can just use this representation of an iterator. So we just basically construct an iterator using our linked iter class. And now the key thing is, what do we pass into the constructor? Well, what's our notion of a linked list within our linked class? Well, it's actually just self. So we just pass in self into this other class so that it can work with that. Now, the reason we didn't do it in this class, it can get very weird to reference yourself while changing it. So generally you don't want to deal with it. It turns out I don't know exactly how to implement an iterator unless you have this extra class. So if you guys can figure that out, go for it. But I think this is just cleaner in general, so that's why I did it that way. Alright, so let us test this out. So we're going to test this out interactively. I'm going to define a linked list of being a favorite linked list. So, okay, it doesn't matter. So this is our link right now. And what we have to do now is, let's just iterate through the link and see if it works. So if we go for every element in my link, I just want to print, see if it works. And I get 1, 2, 4. Great. So let's try this again. See if we can start over. It still works. So because of this, implementing the next method in the iterator and returning an iterable, we have now built an iterator for the linked list class. So that's pretty cool. So before we couldn't do that, but because we've implemented this, we can. Alright, and also, when people actually define linked lists in the real world, it's very useful to have an iterator because it makes some operations a lot easier. Alright, so the next question we're going to look at is deleting from a linked list. And this is going to be a little interesting because instead of deleting from a particular index or doing something at a particular index, we're going to do it in terms of an element. So what this is going to do is it's going to delete the first instance of a particular element from a linked list. And note that in this case, I'm not saying that the link can't be a empty linked list. So here we have to be a little careful. So notice here that I delete this link, so I get the following. And here, well, it turns out that 3 is not in the linked list, so I just return the original linked list. And then here, I delete 6 from my linked list. So I basically take this link out, and gracefully, that ends up being this. So this is a little tricky. So let's see if we can figure this out. So actually, to really help you understand this, I'm going to do some diagramming because I really like diagramming. So we have this right now. So let me move to the next slide. And I actually reserved this slide for doodles because I knew that we'd probably have to do some diagramming. So let's say we have a linked list 1, 2, 3. Okay, so let's think of a pretty easy case. What if we want to delete 1? Delete 1. So basically we're going to take this linked list and chop it off. So how do we do that? So this should just return the following linked list. 2, and then 3. Right? So how can I basically remove this linked list? Well, it turns out that initially we had a link that pointed to this. Well, what if we just made that link point to this? That's basically the same as this. So what we end up having to do is we just return link.rest in that case, right? Because we can just skip over the first element. So that's the key idea there. So let's see if we can, so erase all. Now let's look at a little more complicated example. Let's say I want to take the same linked list. Actually, let's add one more element for it just for a little bit of diversity in our linked list. So let's say I want to delete 3. So that's this element right here. So the linked list I want to return now is the following. 1, that points to 2, and that points to 4. And that points to the empty linked list. So how do I basically cut off a link from a linked list? Well, really this is a smaller version of this problem, because imagine if I just had continued to keep this. So I basically copied this first part over. So I basically slice through this here. I copy this same part over, and now we have the same case where we basically ignore one link and we just point this pointer to this one. So the way we do that is we can basically do a delete operation on the rest of the linked list. Because notice that deleting 3, so notice that deleting 3 from this entire linked list is the same as deleting 3 from this inner linked list and making sure that we keep track of the 1. So what ends up happening is it's just a matter of returning link on my first element in this case. So this is the case where it's not the first element, and deleting on the rest of the linked list. So delete on the rest of the linked list, whatever element I have. So this is the key idea here. So let's now go ahead and implement this. So the first case we actually have to think about, though, is what if the link is empty? So if the link is link.empty, then we can't really do anything. We just return link.empty, because you can't delete from an empty linked list. And turns out that that's actually going to end up helping with this case where we don't have the element in there. Because if the element's not in there, it's going to get to the empty linked list, and then we can just return whatever we have. So then our second case is the case where we find our element. So that just means whatever entry we have, we're currently in the linked list. We just find that it's equal, and then what do? We just skip it, because that means we want to delete that element. So we just return the link.rest, and then at the end we just return link on whatever link we passed, if the case was that the entry wasn't it, and then we delete on the rest of the linked list. And let's test this out to see if it works. And it works. So that's how we delete from a linked list. Okay, so delete's not that bad, but these next two operations are going to be significantly more challenging. So to go into that, so I'm now going to go into how we could go about the process of reversing a linked list. So this is a reverse process, and how we can detect whether a linked list has a cycle. So what does it mean to have a cycle? Well, basically the end of a linked list points to another point in the linked list, and we have like basically a circle going on. And I think with these type of problems, since it's intuitively much harder to see how we can approach this to finding a solution to this, I'm going to go about diagramming it.